Imagine a world where solar panels are everywhere, on rooftops, windows, vehicles, and even clothes. This isn't science fiction, it's the future of solar energy. Hey everyone, welcome back to our channel where we explore the latest and greatest in renewable energy. Today, we are diving into an incredible breakthrough from the University of Kansas that could change the way we think about solar power. For decades, silicon has been the king of solar panels thanks to its high efficiency and durability. Silicon panels convert up to 25% of sunlight into electricity, but they have their downsides. They're rigid, expensive to produce, and best suited for flat surfaces. Now, imagine solar panels that are not only cost effective but can also be applied to any surface, curved, flexible, or even transparent. That's where organic solar panels come in. Made from carbon-based materials, these panels are revolutionizing the solar industry. Organic solar panels are composed of carbon-based materials known as organic semiconductors. These materials can be processed at lower cost and offer greater flexibility compared to silicon. They can be coated on various surfaces using solution-based methods similar to painting a wall. Historically, organic solar panels have struggled with lower efficiency, typically converting only about 12% of sunlight into electricity. But thanks to groundbreaking research and the introduction of non-fullerene acceptors or NFAs, the efficiency of organic solar cells has soared to nearly 20%. University of Kansas team found something unexpected. In certain conditions, excited electrons in NF as gain energy from their surroundings instead of losing it. This is like discovering a coffee cup that heats up instead of cooling down. They used a cutting-edge technique called time-resolved two-photon photoemission spectroscopy to observe this phenomenon. This method allowed them to measure electron energy states with incredible precision, down to a trillionth of a second. Here's where it gets really fascinating. At the quantum level, electrons can exist on multiple molecules simultaneously. Combine this with thermodynamics and you get a scenario where the direction of heat flow is reversed. This reversal allows neutral excitons, those are pairs of electrons and holes, to gain heat from the environment and split into free charges. These charges then generate electricity. Think about the possibilities. Buildings with integrated solar panels, vehicles that charge as they drive, even clothes that power your gadgets. This discovery doesn't just make organic solar panels viable, it opens up a whole new world of energy applications. Beyond just solar panels, this research could also enhance other renewable technologies like photocatalysts for converting carbon dioxide into fuels. The potential impact on our carbon footprint and energy sustainability is huge. By leveraging entropy, a concept usually associated with energy dissipation, the researchers have found a way to actually improve the efficiency of energy conversion devices. It's a game changer. With this breakthrough, we're one step closer to a future where renewable energy is everywhere, affordable, and incredibly efficient. It's innovations like these that will help us tackle climate change and build a sustainable future. Thanks for tuning in. If you enjoyed this deep dive into the future of solar energy, hit that like button, subscribe, and ring the bell to stay updated on all our latest videos. And let us know in the comments, where would you like to see these flexible solar panels used? Until next time, keep exploring the future of energy.